What is F1 computational fluid dynamics, CFD? Imagine trying to see how air flows around a race car without actually driving it. That's what computational fluid dynamics, or CFD, helps teams do. It's a computer-based way to study how air moves around a car's shape and its parts. Instead of building many physical models and testing them in wind tunnels, teams create digital versions of their cars. They then run simulations to see how air behaves in different conditions. CFD works by breaking down the air around the car into millions of tiny, three-dimensional cells. Each cell is like a small box where the computer solves complex math equations. These equations describe how air flows, how pressure builds up, and how turbulent or swirling air becomes. This process gives engineers a detailed picture of airflow patterns, pressure points, and turbulence zones. In Formula One, designing aerodynamic parts like front wings, rear wings, and diffusers relies heavily on CFD. Teams can change the shape of these parts in the virtual world and see how those changes affect downforce and drag. This helps them find the best balance between grip and speed. For example, a team might test dozens of wing designs in a few hours, adjusting angles and shapes to improve airflow. CFD simulations are very detailed, often using hundreds of millions of cells to capture even the tiniest airflow details. They use advanced turbulence models, like the shear stress transport K-omega model, to better predict how air swirls and interacts with the car. Engineers pay close attention to how air moves around rotating tires, how vortices from behind the car, and how turbulent wake affects following vehicles. Even with all this digital power, CFD is used alongside wind tunnel testing. Teams build scaled-down models and test them physically to verify their virtual results. Combining CFD data with wind tunnel results helps teams refine their designs more accurately. Practically, CFD helps teams identify high and low pressure zones on the car. They can optimize wing shapes to generate maximum downforce while keeping drag low. It also helps them understand how air flows under the car and around the bodywork, which is key to creating the suction effect that keeps the car glued to the track. In CFD, the term mesh refers to the grid of tiny cells used in the simulation. Turbulence modeling describes how the computer predicts chaotic air movements. Wake is the disturbed air left behind the car after it passes through. Knowing these details allows engineers to make precise adjustments to improve performance. In short, CFD is a vital tool in modern Formula One. It speeds up the design process, reduces costs, and helps teams develop more efficient and faster cars. By simulating airflow digitally, teams can push their aerodynamics to new levels, giving them a real edge on race day.